All right, so Professor Liu is going to teach you the polymorphism concept. This is our last chapter. Okay, so let's take a look at polymorphism. For example, I have an animal. So the animal can be, this is our base class. That's our base class. So this is our derived class. So cat derived from animal. Dog also derived from animal. Now remember, C++ is multi-level inheritance. So poodle inherit from dog. You may have other cat. I don't know cat's name. Sorry. So class in this program is a structure of inheritance hierarchy. Inheritance hierarchy. All right. So the base class. So we're going to learn something. Um, to how do we derive these? So a base class here, okay, you have this heavily in Java, okay? Now, so animal is the base class. That's a base class. Is that right? So you have a base class pointer. PA is a pointer, point to animal. P is a pointer, point to animal. And you assign that to a derived class. So you can point to a base class pointer can point to a derived class object. Okay? That's kind of confused. Is that right? All right, so that's how we do it. And then we can also do this. We can also do this. We can create a derived class. All right. So derived class has a pointer. So pointer C is a pointer to a derived class cat. And it can assign to your base class too. If you want to assign to a base class, you must typecast. Otherwise, you have mistake. All right, it is so confused. It is because originally they didn't design very good. So this part you must memorize it. So now, so from the higher, you know, from your parent, from higher to children. All right. So children. So your base, your parent. All right. Assign you put your parents pointer, your parents relative, and to derive to you. That's very nature. So we just use pointer is fine. But kids has a pointer. The derived class a pointer, and you're going to point back. It is a little bit difficulty for the compiler to do that. So you have to typecast back, typecast to a derived class. All right. Now, this part, just memorize this. We will not use this heavily. All right. But let's take a look at this program right now. I have an animal class. So let me make this animal class. Okay, we got animal class right here. And I have I don't have private. I just have a function called ID. And the ID just animal. It's an animal. ID is an animal, right? So I am going to have a cat class right now. Is that okay? So the cat class right here, let me push a little bit up, okay? So I have a cat class right here. So the cat class inherit from animal. The ID is cat. ID is cat. All right, let's do another one here. So I have a dog class. So I have a dog class right here. All right. So dog right here right now. So you also inherit from let me make this everything to become 120% so I can feed the entire screen. Is okay? So the animal right here, gentlemen, animal is ID is animal. All right, that's easy. All right. So then I have a dog inherit from animal. That's dog. That's fine. And I have a cat inherit, and the ID is the cat. And that's called no polymorphism. No, this class right here. And I am going to make all right. So let's see this one right now. So we have a bunch of these, but let me open it up, squeeze it, and so that's all right. So gentlemen, ladies, we already saw that animal, and it's our base class, and we have a cat and dog inherit from animal. Now we're going to take a look. How do we do this? All right. So we are going to do this. Okay. So we're going to use pointer. Okay. Uh, Later I'll teach you use reference, but we're going to teach use pointer. If we use pointer, we'll find the problem right here. Is that okay? So animal, I want to create a pointer array. I want to create a pointer array. And so this means in my pointer array, that'll be easier because I want a pointer array. I don't want to do one by one. You can do, say, PA1. Instead of array, you will do this animal PA1 equal new animal, all right, something like that. And animal PA2 equal to new cat, something like that. And animal PA3 equal to new dog. All right, you can do that, but that's, as a programmer, we want to be, if we can do a, you know, uh, if we can do loop, we do loop. So this is how we do it. So animal, I create a array, pointer array. On my pointer array here, and I initialize three objects. First is animal object. So animal object is the base class. New cat derived from animal, and dog derived from animal. Okay. So then we have three. So starting from 0. So guess right here. You already see this, everybody. If you see the animal here, can you tell me if you scroll it down and tell me what's animal's ID here? So remember, if you call this animal ID, and it will say animal. Is that right? Now, next turn is cat. Right? Next turn is cat. So if your cat call ID, it's supposed to say cat. It's supposed to cat. And then let's take a look right here. Take a look here. The third one is dog. So if you call the dog ID, each one has their own function. Is that right? Do we have fun? What's the function all of them have? Can you tell me? Animal has a function called ID. Cat has a function called ID, and dog has a function called ID. So what does animal's function ID will do? Will display what? Can anyone tell me? Please. Yeah, will display animal. Will display animal. Right? Yeah, good job. All right. So can anyone tell me uh, what does a dog, the function dog has a function ID? What does a function ID in dogs class does? Will display what? Will display, anybody can tell me? Display dog. Thank you, Perry. And a function in a cat class. The function in class, there's an ID in cat class. It will display what? Can you tell me? Everybody? Right here, a cat class will display cat. So one more time, we have a base class, animal, and we have a derived class, cat, derived class, dog. All three classes have a function called ID. The function name are exactly the same. The function name are exactly the same, but they display different things. In the base class, I display animal. On the derived class, I display the derived class ID, the dog and the cat. Ideally, when I run this program, I will have animal display animal. I would have cat display cat and dog display dog. If I'm successfully to do that, then I have polymorphism completely. Polymorphism means in my base class, I give you a general code, and then add your derived class. At the derived class, I write the code. All right, so that's running right now. So I build there. And I start without debugging. Now, gentlemen and ladies, notice my result is all three of them say animal. All three of them say animal. So the result is quite disappointed. The result is quite disappointed because the result is showing you here. All right, so everything is animal. So it does show you that we don't have a polymorphism right here. All right, so you print animal. So we totally, this compiler ignoring the specific version of ID, the dog and cat. Why is like that? Because the your C++ default will go back to your base. It will go back, the code is go back to your base. It will only see when your base class and your derived class have the same method. The name are exactly the same. That's at this moment we'll take the base class code as your code. So your derived, nobody care now. Right? Then we are going to make it somebody care. If you want to make it care, then you have to make your base class less important. So that's virtual, like less important. All right, so we are going to modify that. But before we modify, I need you to create your first program. And the exe file is no polymorphism, because this one is no polymorphism exe. All right, can you complete that? And I hope you understand this program. I hope you see, at least you see there's no polymorphism. There's a everybody should follow your base class method right now. So I hope you understand this program and understand uh, uh, the problem. If you use this way in the polymorphism in C++, then we are going to create it, correct the error with the virtual function.